Hello everyone, welcome to Heat Transfer SEMM3443. So now we'll be talking about the video that we just watched just now. So through the video that we just watched just now, there'll be two types of heat transfer method that we'll focus on. First thing first is radiation, which is emission of electromagnetic rays, which we can see from the gas stove, transfer the heat through radiation towards the pot itself. Yeah, and then we can also see convection where there's movement of hot fluid inside the pot itself. Yeah. And then next we'll look into factors that influence the rate of convection and its equation. So one of the factors that affect the rate of convection is the surface geometry, whereby bigger surface geometry increase the contact surface area between hot and cold fluid. And next is the nature of fluid motion, whereby the higher the velocity of fluid motion, definitely the higher the heat transfer rate. And then next we'll look into the properties of fluid, whereby density and specific heat capacity of the fluid. It will influence how much the heat can carry and also how quickly it can transfer the heat. So different fluid have different properties and also different reaction towards the heat transfer. And when coming towards convection, we'll be talking about Newton's law of cooling. And in this Newton's law of cooling, we'll focus on the heat transfer rate for a convection process, which the equation is H times A, which is area, times the difference of temperature. So what is H? So H is actually not the property of the fluid, but H is actually the heat transfer coefficient. And H is influenced by the type of fluid motion is linear or turbulent, and also the region of the flow developed by the fluid itself. Yeah, so that's all from me. Thank you.
Okay, thanks Clement. So for now, I'll be explaining the factors influencing the radiation and its equation. So the first factor that will be influencing the rate of radiation will be the surface geometry. So as you can see, different containers will have different surface of geometry, and that's why the rate of radiation will be different too. So for the surface wise, it will actually influencing like whether the material will allow more or allow less radiation exchange. While for the shape wise, it will be actually influencing how the radiation is going to emit or going to be absorbed. The second factor will be the absorptivity. So as you can see, the symbol will be alpha here. So the absorptivity actually determines like how well a surface absorbs radiation, and an object with high absorptivity also means that the object can absorb more radiation and consequently can emit more radiation as well. The last factor will be the emissivity, and the symbol will be epsilon. So for the emissivity, it will be the range of value will be between 0 and 1. So the emissivity is defined as how efficiently a surface emits radiation compared to a perfect black body at the same temperature. So once again, a surface with higher emissivity will actually emit more radiation, and since a black body is going to be used as comparing purpose, so for the black body wise, the absorptivity and the emissivity is equal to 1. And with that, actually that's all for the presentation from our group. And thank you very much, Doctor, and we shall have a nice day ahead. Thank you.